Good evening all. We'll get started in a couple of minutes. Good evening. We'll get started in maybe a couple of minutes, as people might join. Okay, we'll get started. So this week, the most of the discussions are pertaining to principal component analysis, naive-Bayes algorithm, and then finally we'll touch upon SVM. So first question is on principal component analysis. So the objective in any of these in this analysis is essentially you have an input vector x of some particular size, say dimension n. You are trying to convert it into some other vector m of dimension m, y of dimension m, such that m is less than n. So when you are doing this transformation, which of the following operations will be like the particular transformation will be invariant to? Translation, rotation, or scaling. So if you have say two-dimensional data, if this is my data set, so these are my original vectors x1 and x2. After doing PCA, what I would be expecting is to get a new set of axes to represent the same original data, say something like this. So if when I do this transformation, which of these it will be invariant to? Translation. So if I translate all my points, say I translate my x prime equals to some x plus h. So all my data points are translated to new coordinates x prime, and I apply the same transformation and apply my PCA algorithm on that. I would be getting some other answer. Say I will get y prime. So will y prime and y be equal? Or in other words, it's as if like this is what my PCA is doing. all it does is essentially tries to reorient your axis in such a way that the new axis that you have chosen will be able to represent the data in a much better way than the original ones. Or most probably in this particular example that I have shown here, your input also has 2 features, output also has 2 features, so it is not much evident. But usually what happens is when your input might have 3 features, and then after performing PCA you will end up with having just 2 features, so you will essentially have a dimensionality reduction. So the question asks you, so if I shift my axis, so instead of this x and y, if I shift my axis to something like this, say x1 prime and x2 prime, will the output, this orientation y1 and y2 will change or not, just by shifting the axis? I hope the question is clear. So what are we trying to do in PCA is we are trying to reduce the variance associated with it. So whatever axis it chooses, along that axis you will have your most of the variance will be explained only along that particular axis. So by translating, what we do is in any of this PCA operation, the first step is you rescale or basically shift to center. So the first thing it does is normalizes your data and then shifts the centers in such a way that even if you do this translation or rotation operations, your final output is not going to be affected by that. So it's just that all your data points are now represented in a new different axis, but that doesn't change the fact that the variance of the data will be changing, because variance of the data will actually depend on the values of data points. In a relative sense. Not in the no, it doesn't depend on the absolute value of that particular data point. Instead, it depends on the relative values of these data points. As long as these relative values are kind of remaining the same, your output of PCA should remain the same. So when you do translation or rotation operations, the relative value is not going to be affected, so your PCA won't be affected by that. But however, when you do scaling, this variance could actually be increased. So this is a scenario where your PCA will be highly sensitive to it. So whenever you apply this PCA along different features, you need to ensure that they are appropriately scaled. Say for example, we will see one more example in maybe a couple of problems later. So if you have excess, so say you have n features. So by scaling, what I mean is you scale all along, say if you have capital N samples, you scale only along this dimension and then along this dimension, along this dimension. So you'll end up with having something like x1 bar, x2 bar, xn bar. Say suppose you are doing min-max scaling, and similarly you have n samples. So what is x1 bar? x1 bar is essentially x1 minus minimum of x1 along that column by max minus min. This could be one kind of scaling, or you could also do the mean variance scaling. Whichever scaling you have chosen, you do for each and every feature and then you perform PCA on it. Otherwise, what would happen is, say you have x1 varying from say -1 to 1, and x2 will vary from say -100 to 100. So in this particular scenario, what would happen is obviously variance of x2 will be greater than x1. Then when you perform PCA, it will choose the one which has maximum variance, so it will give more weightage for x2 than x1, which is ideally not the case. So that is why you have to perform appropriate scaling before doing your PCA. I hope this is clear. So it will be invariant to translation and rotation, but it will be not invariant to the scaling operation. Are there any questions, or is this clear? Clear. Okay. So after PCA, we have this week discussed on naive Bayes classifier. So this particular question asks you, it's a very simpler version just to make you understand how the algorithm works. So you are trying to model is OR gate. So OR gate is basically you have two input x1 and x2 and your output. So it says the input training data is 1 0 0 1 and 0 0, the output will be OR gate, so you have 1 1 0. So this is my training data. Now I want to train a naive Bayes model on this. So how would that be? So first step would be to identify what is the probability of y equals to, say, particular class, any one of the class, given some values of x1 and x2. This, if you apply Bayes theorem, that will be proportional to x1. After the naive Bayes approximation assumes that these are independent, so you can write it in this way: x1 equals to some particular value, y1 equal to some particular x2 equal to some particular value times probability that y equals to 1. So in order to do any of the prediction, so similarly you need to know what is the probability that it belongs to class 0. So in order to do the prediction, once a particular value of x1 and x2 are given, I need to calculate these probabilities. When I multiply, I'll get the values here. Say, let us say this is p1 and let us say this is p0. If p1 is greater than p0, I would say it belongs to class 1, or I'll say the output is 1. Otherwise, I would say the output is 0. If this is my decision, this is how I decide the final output of the particular model. So how would I calculate each of these values? What is p of y equal to 1? P of y equal to 1 is essentially the probability of y equal to 1 in the training data set. So this is from the training data. So you have 2 out of 3 data samples, and similarly y equal to 0 will be the other one, 1 over 3. So how would I calculate p of x1 given y equals to 1? Or essentially in this case I would be actually requiring both x1 y equals to 1 and y equal to 0. So let us write it in the form we were familiar with before, which we were using. So y can take two values, 0 and 1, and x1 also can take two values, stick to the same thing, 0 and 1. Now if I fill these values, so when y equal to 0, what is the probability that x1 is 0? So y equal to 0, what is the probability that x1 is 0? There is only one instance of y equal to 0 and x1 equal to 0 in that particular instance. So what is the value of this probability here? The first one, 1. So similarly, when y equals to 1, what is the probability that x1 is 0? Yeah, so I think you got the hang of it. So now you do the same for others. So when y equals to 0, what is the probability of x1 equal to 0? You don't have anything. So this will be a 0. And similarly, when y equals to 1, you have two instances. The probability that x equals to 1 is only half. Similarly, you can calculate the second one. In this case it is symmetric, so I think both the probabilities will be same. So have 0 1. So y equal to 0, the probability x2 equal to 0 is only one instance, so this is 1. Y equals to 1, it will be half, so the other ones will be 0 and half. So now I have trained my model. These are the parameters of your, like, you essentially don't have any other parameters, so these are the things that you would be requiring to predict the output from your model. So using this information, how would I calculate this? First one, say p1. If I want to calculate p1 for say x1 equals to 1 and x2 equals to 1. So this is my testing data. So when you train the model will essentially calculate all these probabilities from the training data set. Once this is done, so now I have to predict it. So what will be the value of p1 using this relation? So p1 is essentially probability of x1 equals to 1 given y equals to 1. x2 is also given to be 1 times y equals to 1. Probability of y equals to 1. So we have all the values. So all the value, we have all the values here. So x1 and y1, both of them to be equal to 1 is probability of a half. x2 equals to 1, it will be similar, and probability of y equals to 1 is 2 by 3. Yeah, so this gives you 1 over 6. What will be the second one? P0. Okay, before going there, can I write it directly as 1 minus P1? Can I write P0 to be 1 minus P1? Instead of using relation like this, can I directly write P0 to be 1 minus P1? Since the output can only be one of these two values, y can either be 0 or 1, so can I write it this way? Yeah, probably not. Why so? Yeah, so if you see, if this is the actual probability that I have calculated, I should have been able to write this. The only problem is I have just used the proportional here. So you have to, in order to normalize this, you have to add both of this. So ideally, say if I define P1 prime to be something like P1 by P1 plus P0, and P0 prime to be something like this. If I define P1 to be something like P1 prime to be this, then I can write in this way. Since I am just using the proportionality without the evidence, or in the sense I'm not dividing here. This should ideally be divided by probability of x1 and x2, which is something that I have not written, that I have not done here. So without that normalization, you cannot directly use 1 minus P1. So I hope that is clear. So now that we are not using that, so we should stick to our formula here, so which gives you probability of x1 equals to 1 given y equals to 0, and similarly you have x2 is also given to be 1. So what will this give? x1 equals to 1 and y equal to 0 is probability of 0, 0, and then you have 1 by 3. So in this particular case, it so happens that P1 is greater than P0, so your output will be 1, which will actually be true for an OR gate. When you have both x1 and x2 equal to 1, your output should be 1. So that is something that the same is what you got from the naive Bayes classifier. So now this is for a discrete data set. In a sense, here we have x1 can only take two possible values, 0 and 1, and similarly x2 is also based on a discrete values, and that is why we were able to calculate the probabilities x1 given y equals to 1 or x2 for some particular values. So what if x1 is a continuous number? Say x1 belongs to some real number and x2 is also some real number. So basically they are some continuous values. Okay, I shouldn't say real number. Say x1 and x2 are continuous variables. So how would I change this? One straightforward thing is I cannot directly calculate the probabilities here. You would be using something else. So what is it that you will be using there in case of a continuous data? So if you recollect, so in this particular case, these are something called discrete random variables. I may assume that my input is a discrete random variable, but now what I am asking is, if it is a continuous random variable, you wouldn't be using the normal ones, you should be using some other probability distribution. So what are those, which distribution could you possibly use is something that you have to choose depending on your data set. So say you can use a Gaussian distribution. There are several other distributions that you can use. Say we'll stick to Gaussian distribution. So we'll also take up one problem on how to use Gaussian distribution for a continuous one. So the idea is very similar to what we have done here. The only difference that you will be having here is instead of these probabilities here, you will have PDFs. That's the only difference that we'll be having. Okay. So coming to the last point, so we also discussed on this called class imbalance effects. So basically when you are training, you have two different classes. In this particular case, you can see that probability of y equals to 1 and y equal to 0 is not equal. Ideally, if you consider the original OR gate, the probability of y equals to 1 or is essentially half if you consider all the data sets, I mean all the training points. So you have all instances, probability of y equals to 1 is, so 3 by 4 and 1 by 4. This is my original data set, but instead of this data set, I am using a reduced data set with different probabilities. So I have something like this. So basically I removed the last data point. So this is something that I have removed. So instead of 3 by 4, now I have a different probability, and instead of 1 by 4, I have a different probability. However, this is basically when you're, so what should be naive Bayes algorithm if P1 becomes equal to P0? Yeah, that, okay, if both are exactly equal to each other, then both are equally likely to happen. So it wouldn't give you any useful, like you cannot basically trust the output of it. Your model hasn't learned anything. There is nothing, yeah, so there is nothing you can do with naive Bayes. So if you know that one of these class labels, say in that particular scenario, if you know prior that one of the classes is more probable than the other ones, then maybe you can decide from that. But the prior information is already included in it, so you can't use naive Bayes. Like essentially, it won't be any useful. It doesn't provide any valuable prediction from in that particular scenario. So, anyways, naive Bayes is something that you be using always. Now, coming back to our question, what happens when you have this imbalance? So instead of training on a data of this probability, this prior, you have trained on some different prior. In this particular case, it didn't affect your output anyways, but in some scenarios when you have different probabilities than the ones that you ideally need to have, then again you need to offset, like your model is essentially biased towards one of them. So it's 2.5 and then you have 0.33. So basically your model is now biased more towards the class y equal to 0, which is something that you might have to avoid. So this we have, in case of using gradient descent and things like that, we have discussed on several other methods also. Even in the last week when we discussed on k nearest neighbors, in order to overcome this, what were we doing? So how do you overcome this imbalance? Say if you are using KNN or something. KNN is a non-parametric method. So how do you do the, in KNN, when we are doing the inference, we actually increase the weight of this particular ones that are less biased. So for example, y equal to 1, we know that the representation is less, so basically we increase this by some factor k1 and k2, so that this bias is kind of minimized. The error that you get because of this bias will be kind of reduced. This is very similar to what we done in KNN, or even before that when we were doing the gradient descent also. Is the idea clear? So the next question is again on PCA. So this is your input data set of you have n is number of samples and n is your number of features, and then you attempt to transform it to a new vector y of the number of samples will remain the same, but the feature will be size k. Obviously k is less than n or equal to n. This is something that we are expecting from PCA. So the steps involved are, first we have to scale this along the dimension n. This we have discussed, because if you do not do the scaling, variance along one particular dimension will be much larger and that will outweigh everything else. So you have to scale along, rescale everything along individual features. Next you determine the covariance matrix. Once you find the covariance matrix, you determine the eigenvectors of that particular covariance matrix and then use them to transform the input vectors. So these are the steps you follow. Finally, you choose the k less than or equal to n or equal to n and retain only k features from this. So these are the steps you follow for PCA. The question now is, if the matrix y is further used to train another prediction model, whatever output you get out of the PCA, so x is something I have as input and then I perform PCA, and then I have some output y, and from this output y I am predicting something else, say y hat, or let us say 0 or something. So this I am using, say, neural network here. So I use a neural network. The input of the neural network is the output of the PCA. Comment on what would be chosen as basis in deciding the value of k. Okay, if this is something that is a workflow of my model, so how would I choose the value of k? I know k is less than n. In normal PCA, if you do not have this downstream tasks, what you would be doing is once you get the covariance matrix, like you would be getting the eigenvalues, and then you would see something like this. Say you have 3 features as your input, then you would have 3 eigenvalues, say lambda 1, lambda 2, and lambda 3. And once you do the transformation, after you do the transformation, you would have these values, and say you have a cutoff of out of these 3 values. Usually it so happens that a couple of values will be much lower than the other value. Say, let us say lambda 1 is greater than lambda 2 is much greater than lambda 3. If you have a scenario like this, then what you would be doing is the most of the variance in the data set will be explained just with this 2, and you can kind of neglect the third one. That is the main idea in your PCA. So you then you would only choose these 2 eigenvalues, and then from there you would do the transformation. Basically, you will not use x of say n by 3, you transform it to y of n by 2. This is what you would do in a normal PCA. Now when you couple it with another neural network and you want to get a final output z, now what you would be doing is, how would you decide k is, again you can try for k equal to 2, k equal to 1, and so on, and then you would see for which one of these z is actually predicting much better than without this transformation. Or maybe we will take up this problem a little later when there is one more problem. Okay, we'll come back to this problem. The idea here is you would actually vary k and then see which one of the k is actually giving you much better output than the original one, than using x directly. So if you are using n, you get a z, versus you use k, you get say z prime, say z1 and z2. Which one of these is actually useful is something that you want to answer. So how would you like, you can directly implement with n, you would directly implement k, and then see which one of them is performing better or not. Alternatively, can I comment directly without actually without actually developing any of these models? Can I comment on anything saying that z1 is better than z2 or something? Is there any way I can comment on saying that this second step is much better than first step? Yeah, so that is the question I'm trying to ask. So is there any way I can comment on saying z1 is better than z2 or the other way around? So that is a question we will try to answer maybe a little later, but just keep that thing in mind. So we will come back to that question again. Let us say these are your data points, so x1, x2 and x3. Say we have some data, and I have y is my output. Let us say you do not have the second part, so basically you do not have the y component for now. You are just treating the input data set as is. So in this particular scenario, what would be my principal components? So how would I do that? First step is to calculate the covariance matrix of this particular data set. So what would be the covariance matrix? How would I calculate the covariance matrix? I'm not going to do the calculation, but I can give you the values directly. But how do I calculate covariance of this particular one? So in exam, if you are asked to calculate covariance, the first step is to calculate the mean of each one of these along different samples. So the mean for this is 1. You have once you have the means, how do you calculate the covariance? you have here you have 3 features, so you would be having a 3 by 3 matrix, which is 1 1 1 2. Say if I want to calculate x1 and x2, how would I do that? This n over here is, okay, I should have added one more value. So what would be the value of n here? This n is the number of samples. In this particular scenario, it is equal to the number of features, but ideally this is the number of samples, and from this you would calculate x1 and x2. Similarly, you will do for all other values, x1, x1, and then different values. And once you get the covariance matrix, you can calculate it quickly, or maybe okay. Can you calculate it quickly? Or if you were to calculate the covariance matrix and then you find the eigenvalues from there, what you would observe is, I have done the calculation, I will post a solution, like there is some issue with the network, but once you can directly do it in MATLAB. You can directly use covariance function, and then you can use I function to get the eigenvalues. So you will happen to see that there will be something which is close to say -16 or something, and then you will have something like 17 or so, and then you have 6 or so. So basically out of these 3 eigenvalues, only 2 will be dominant and the last one will be less. So you can use just these 2 eigenvectors as your basis instead of using x1 and x2, x3. So using those 2 eigenvectors, you can train your model. So now when you add this y also into your data set, and repeat the same steps with the 4 values now, including y, you would again observe when you do the same, here what you would observe is only one of them is dominant instead of all 3 of them. So basically your y is actually dependent only on one of these values. So basically in this particular example, I have chosen y to be x1. So basically it should be irrelevant of x2 and x3. So you will observe that these values will actually go off. So what I was trying to emphasize here is, if in the scenario when you have redundant features, using PCA will actually remove those redundant features, and then your neural network will be able to better predict than having these redundant features, because you will be having lesser weights and it will be much easier to train than the one with so many redundant features. So when you have redundant features, the neural network has to learn this additional thing that these features are redundant. That is something that we are avoiding when you use a PCA. I cannot give you the values right now, or just give me a second. I'll try to log in. Yeah, so here I've taken one more extra value. Instead of 3 samples, I've just taken 4 samples, just to differentiate that between number of samples versus your number of features. So once you calculate the covariance, you happen to see that you have, out of these 3 eigenvalues, one is actually much lesser than the other 2. so you can actually use only 2 of them. Now in the last scenario, when you kind of implement it, like once you do the transformation, how do you do the transformation? Once you have the eigenvectors, you multiply these like MATLAB gives you right eigenvalues, so you just multiply x times v instead of v times x. Like if you happen to use a left one, then you will be doing v times x. MATLAB gives you the right eigenvector, so I multiplied x times v. So these are my new features. In this particular case, I have considered all 3 of them, but ideally you can remove the first one. So basically, you'll remove this minus 0.9416 and then use the other ones. From there, you will get the new transformation. Once you use the new transformation and then scale it accordingly, so now you have these as your 3 principal directions. So what I am saying is I will drop off the first component, since the eigenvalue is much lesser for the first component, so I will drop them off and then to see the covariance. So this was able to explain, these 2 were enough to explain most of my data set. This is what you do in a normal one. Is the process clear of how to do with PCA? Yes. Now coming to the next part of the question is I want to club this whatever the output I got previously from my PCA, I want to use it to train another neural network. So since I have reduced my number of features, neural network will actually be better able to predict than the previous one. That is the claim I am making now. So this is the claim I am trying to make. So whenever the number of features is reduced, in that particular scenario, you will have a better performance because of your increased quality of the lesser number of features you have on your model. This is the claim I am making. So I cannot prove you that it works. And let me ask you one more question. So will PCA always be useful? So basically I am reducing my dimension. So in some scenarios, you might lose some features which might be relevant to your output. So PCA may not always be useful. So there can be scenarios where your PCA can actually reduce the performance of your downstream model. So whenever you use PCA, you need to club it with another model and then finally do. This is something that will come again, return to it again when we discuss on autoencoders. So it's not PCA, it's a variant of PCA that will help you to train a model from end to end in such a way that whatever features that you are that you develop in your low dimensional space are relevant only to the downstream task. Is the idea clear? So what I was trying to say is, when you are trying to reduce the dimension of your input space, it should be done in such a way that whatever downstream tasks are there, they should be more efficient than without doing this dimensional reduction. That is the whole idea that will take up in autoencoders. That is something that is not included in your PCA directly. This piece, because here you do not depend on your downstream tasks. All the PCA does is essentially try to reduce the variance associated with your particular representation of your data. That is what it does. So can we say that reduces the chances of overfitting? Yeah, as I said, like PCA doesn't care about what is happening in the model. All it does is it just changes the way you represent your data in such a way that it will reduce the variance of it. The variance of input representation, not the model. Overfitting is something we discuss of the model. Here we do not have any model in the first place. So if X is your input, all we do is get some Y and this goes into model. Overfitting is something that you are talking about this model, right? This is not something we are PCA is dealing with. All it does is reduce the variance associated with X. It will try to reduce the number of features, that's it. How does it help in overfitting? Is if you modify it a little, that we will discuss in autoencoders. Okay, now that is clear. Let's come back to next question. So yeah, previously we were using naive Bayes on discrete data. Now let us see how to implement it on, say, continuous data. So here you have 2 variables, say x1 and x2. So both are coming from uniform distribution, and the decision boundary is given by x1 greater than or equal to x2. So this is my domain 0 to 1. So say x1 greater than or equal to x2, let us say this is y equals to 1 and the other one is y equal to 0. So this is my decision boundary. Now I want to train a Bayes model on this. So what are the steps are basically, first, like before, we need to know what is probability of x1 given y equals to say 1, x1 given y equal to 0. We also need to know what is y1 equal to 1. Sorry, there is no 2. These are the ones that a model needs to learn first before it can do any predictions. So how do I calculate this? So I need to determine all these 6 values. Once I have all these values, I can do any of the predictions. Say if I want to predict the probability of 1 given some particular values of x1 and x2, I will use these values. So out of this, say how do I calculate each one? Say first one, what is the probability of y equal to 1 from this for this particular problem? If both x1 and x2 are uniform distributions, are coming from uniform random variables, so what will be the probability of y equals to 1? Yes. So in this case, both are equally likely. So you have 1, and probability of y equal to 0 is half. So there is nothing much here. So how would I calculate the other one? Say probability of x1 given y equals to 1. So what the question asks you is assume a Gaussian random variable for this one. So basically we will assume that this comes from a Gaussian distribution of some particular mean, say mu 1 1 and say sigma 1 1. I am just giving some numbers here as subscripts. 1 1 basically refers to the variable x and this refers to the variable y. So this is x1 and predicting the value for class label y equals to 1. So how would I get this mean and variance is, once I have my data set, mu 1 1 is essentially your mean for this particular scenario, mean of your x such that your y equals to 1. So you take all the instances where y equals to 1 and then you will have certain values of your x1 and then you take a mean over all of them. That will give you the mean of mu 1 1. Similarly, sigma 1 1 is for the same set, you will get the standard deviation. This will give you the first distribution. Similarly, you do for the other ones. Probability of x1 given y equal to 0, y equals to x2 given y equal to 1 and x2 given y equal to 0. Now once you have all these probabilities, then for whatever outcome you want to predict, so the second part asks you if x1 equals to 0.3 and x2 equal to 0.6, you use these distributions to calculate the PDF of those. So you can get this value using the, so what is the distribution you will be using for normal is something like, in this particular case it will be 1 by root 2 pi sigma 1 1 square times exponential of whatever the value of x1 that is given, that you want to predict for, minus so this will give you the that when you substitute that x1 and you already calculated mu 1 1 sigma 1 1. It's like mu 1 1 and sigma 1 1 you calculate from your training data. X1 is something that you will be using for your testing data. Once you substitute that, you will get a value here. Similarly, you will do for the other one, and you already have the probability of y1. So you, from this you will get a value, say p1. So this is for predicting for class label 1. You do the same thing for the other class label and see which one of them is greater. If one is like your final output will be the one which has a greater probability. This is clear? So I've just taken x1 as my random variables. I've just taken 100 samples, x2 is 100 samples. Y is basically I'm taking y equals to 1 when x1 is greater than or equal to x2, and otherwise it will be 0. So first one is mu11 is essentially mean of x1 for the instances where y equals to 1. So in MATLAB the command goes like this. So x1 only consider instances where y equals to 1. So that gave you a mu of around 0.69 something. So ideally, if x1 is a uniform distribution, what would be the value of the mean of x1? So what is the maximum likelihood estimate for a uniform distribution, for the mean of uniform distribution? So if your uniform distribution is 0 to 1, the maximum likelihood estimate is half for uniform distribution. Now for this particular scenario, when you have y equals to equal to 1, your mu's have been offset. Ideally, if you just do for x1, it would be 0.5. Now because of your class label, it got shifted to 0.6985. And similarly, you calculate the standard deviation, repeat the same for y equal to 0. Now you have all the distribution corresponding to probability of x1 given y equal to 1 or 0. Similarly, you do for the second variable x2, or how many other variables you have. You calculate all these mean and standard deviations. Once you have, you already calculate the, in this particular case, probability of y1 is ideally it should be 0.5, but because of this randomness, I've just used 100 samples. So if you use maybe say 1000 or 10,000 samples, then it will be much closer to 0.5. Just because I've used lesser samples, it's close to 0.5, 0.54 and 0.46. Once you have these probabilities, I want to use this model for an inference of x1 equal to 0.3 and x2 equal to 0.6. So norm PDF is the MATLAB function to calculate that 1 by root 2 pi sigma square exponential of minus x minus mu, whatever expression we have written previously. This is the particular point, and mu11 std11 similarly times x2 mu21 and sigma 21. So that gave me a probability of 0.13 and the other one is 0.12. Now I am reiterating here, like this is just proportional to it. We are not doing any normalization. That's the reason that P0 is actually greater than 1. If we were doing the normalization, we would actually get it every value of these probabilities to be 0 to 1. Here we are just using the PDFs, so it is not a CDF. So these values can actually be greater than 1. So and you compare P1 and P0, which one of them is greater, you will decide your class from that. So this is clear, like this is straightforward. This we are assuming that it follows a Gaussian distribution. Say maybe now you should be able to answer what would happen if I, instead of Gaussian, if I would assume a uniform distribution. Can I use a uniform distribution? Like in this particular scenario, I have used a Gaussian distribution. So how would I change it if I were to use a uniform distribution? So what I am asking is, if you have x1 given y equals to 1, I want to approximate with a uniform distribution. So how would I go ahead? So what would I do here? So first we have already done assuming it to be Gaussian distribution. So I have some parameters, sigma and mu. And from there I have the PDF of Gaussian distribution. From there I predicted everything, so it went well. So what would I do for this case if I want to have a uniform distribution? So how would I construct a uniform distribution? So I know I need to construct a uniform distribution of some, I need to know both the upper and lower limits of it, say a and b. So how would I determine the values of a and b? So can I take a to be 0 and b equals to 1? Or do I have to do something else? Okay, let me ask, let me change this, let me rephrase the question. So in case of a uniform distribution, what is my mean? Just now you told it's a plus b by 2, 0 to 1. So what will be my standard deviation for a uniform distribution? b minus, that is sigma square. Okay. So that is essentially variance. Okay. So now you have two equations. So you already calculated the mean and variance for your data set. Based on your data set, you calculate your mean and variance. So you have some value here, you have some value here that you already calculated. So from these two equations, two unknowns, you would be able to find the correct values of A and B. Once you calculate these values of A and B, that will be the uniform distribution that you should be using instead of A equal to 0 and B equals to 1. I hope the idea is clear. However, even after doing this, the problem comes here. So whatever be the value of x1 that you have chosen, as long as it lies within these particular values of A and B, this number turns out to be 1 and this number turns out to be 1. So all you would be end up is having p1 equals to half, and the other one will also be half. Only when x1 and x2 are exceeding these particular values of A and B is when you will have some prediction power. Otherwise both this p1 and p0 will be equal and you won't be able to predict anything. So we usually don't use uniform distribution, and we'll stick with Gaussian, or you use Bernoulli or some other kinds of distribution instead of uniform. Is it clear? So why we are not using uniform? Or just to put intuitively, what it means in uniform distribution is you don't know anything about it. All you know is any value of x in the particular range is equally likely. That is what a uniform distribution says. That is something which doesn't give us any predictive power. Gaussian distribution will tell you that a particular value, all the values close to one, say Gaussian distribution goes something like this. So all the values close to this particular mean are more likely than others. Here you have more information or more predictive power than saying that everything is equally likely. This is what a uniform distribution says. Maybe this might be more intuitive than the previous mathematical one. So is the idea clear? Yes. Okay. This is a little theoretical, or to say a little concepts on fluid. So what the problem tells is, say you have a straight pipe. To those of you who are from different domain, so say you have a pipe and some particular fluid is flowing through the pipe, and this pipe length is say L and this diameter is say D. So for this particular flow to happen, I'm just giving a very vague explanation. So you are in order to have this fluid flow through this particular pipe, you need to connect it with some pump or motor or whatever, like a pump or say compressor or whatever. You will be connecting a pump or something to it. What the pump does, it kinds of compensates the pressure drop that is created inside the pipe. So that is the whole idea. So the problem here gives you the relation between the pressure drop. So there is some pressure P1 and P2. This pressure drop is related to the geometry as well as the material properties of the fluid through the particular relation here. Something like this. Say if the relation is already given to you, the relation can also be written in a slightly different form with some of these non-dimensional numbers. We discussed previously, like when you use PCA or principal component analysis, what we were trying to do is we are trying to reduce a dimension of our original problem. So originally for this problem, I have two material properties, one flow property and two geometry properties of the pipe. So basically there are 5 variables in total. However, my final answer will only depend on these 3 variables, which again f is again a function of Reynolds number, which is kind of a clubbed parameter of these values. So I can reduce my dimension from 5 to 3 and train my downstream model, essentially predict my delta p in terms of this. So this is again a regression problem. So you have mu rho VLD as my input and f is my function. This should give me delta p. The first part of the question asks you which regression model you would use to fit this particular model. Can I use linear regression? Linear regression is directly out of scope because you have seen terms like this. So it won't be able to predict v by d square. So linear regression is out of question. You can't use linear regression. Which regression model will I use for this particular problem? Can I use a decision tree? Can I use a neural network? say A, B, and C. A is out of question because you have some non-linearity here. You will not be able to do anything with linear regression. Neural network should work. It should be able to capture. So decision tree. Decision tree might not work directly with these 5 features. However, so basically you are convinced that neural network might be able to predict it better. So now that so basically if you were to use neural, excuse me. Okay, if you were to use the neural network, so can PCA help to reduce the number of the dimension of your problem from 5 to 3? Say I have originally these 5 variables. If I use PCA, will it be able to give me these 3 new variables, like whatever these 3 features are? Or to put simply, all I am asking is if these are my input dimensions, I want something like 64 mu by rho VD as my first feature, L by D as my second feature, and half rho V square as my third feature. So this is my input and this is my output. So can PCA do this transformation? We have discussed like everything that PCA does is it essentially transforms the input in some way to get some new values of your features. So can PCA do this transformation? Okay, so again not sure. Okay, so if you recollect, so what PCA does is, say you have some samples like this, all it does is identify that particular transformation that will be kind of say if these are my original ones, it will try to give new axis. This is what it does. All it does is this. And if it so happens that this particular variance associated with this particular axis is very much less than the variance associated with the other axis, it will kind of drop off one axis than the other. So all it does is this rotation or some kind of transformation. So if this is my x1 and x2, the ones that you get later, say x1 prime and x2 prime, will again be a linear combination of x1 and x2. So it will something go like some W transpose times, or let us say W1 x1 plus W2 x2 plus B. So essentially this line gets rotated, so you can represent it again with a linear transformation. So all the PCA does is essentially do this linear transformation. And if you see the transformation that we want here, the transformation we want here is something that is non-linear. So this is something that cannot be done with PCA. This is one kind of a limitation that we want to explore further when autoencoders come. So how do we do it for non-linear components? So if you want to do transformations like this and come up with new features, you need something like a neural network that can capture these non-linearities. So how can I use a neural network to perform this dimensionality reduction? That is a question that will be answered later. For this particular problem, I think the conclusion is clear. So PCA won't be able to do this transformation because it is not a linear transformation. I hope this is clear. Yes. Yeah. So this is what we were trying to say. So if you have PCA, X is your input and Y is your output. you want to do this particular transformation, and this transformation can be represented, if it is a linear combination, I can just represent it with this W. So all I want to do is now find this W. How can I find this W? I can parameterize this with a neural network. Say I parameterize with a neural network. So y equal to x times W. How will I find W? I cannot directly do, like in neural network what we were trying to do is we will try to minimize, say, y minus y hat or something. We have an objective function, we try to minimize this using some given data set, we will try to finally find out the value of W. The only problem here is we do not know the values of y. Here we have two unknowns, y is something that we do not know and W is also something that we do not know. So we have two unknowns and we will not be able to solve it directly. So what is usually done is you have your input, you have some particular transformation W1, you try to have this y and then come up with another transformation W2 to find the values of x. So basically you will use x as your input and from there you will get some transformation y. So if this is of dimension, as per the question it is of dimension m, you reduce it to k less than m, and then you use another transformation to find x of the same dimension, and then your objective function will say, let us say this is x hat. Your objective function now will be to minimize x hat minus x. With this objective function, for any given value of x, and x is the actual value, x hat is the one that your neural network predicts. This entire transformations W1 and W2 will be replaced with neural networks. So by minimizing this loss, this is what is called a reconstruction loss. So when you train your model on this, it will be able to find out that's W1 and W2. So it will not only identify your forward transformation, it will also calculate your inverse transformation. So it will, from there you will be able to get this low dimensional space that will be useful for your other tasks. So coming back to the previous one that we discussed previously, like if you have some downstream model that you want to work with, so you want to use this particular y with some other model to predict something called z. So now your objective function will essentially have both of this. So you will have to minimize x minus x hat square, and also you have say it is z minus z actual whole square. So by minimizing both of this, you will actually identify that particular transformation that will ensure the reconstruction loss is minimized, as well as this particular model is also trained better than your original input. So this is something that you cannot do natively in your PCA. Is the idea clear? There are several questions that need to be answered. The first one is in PCA, all your whatever transformation you have used in, all the components should be orthogonal to each other. How do you ensure the orthogonality is one question. Or essentially, to put it very simply, whatever features that you are generating in y, each of these features should be independent from each other. That is to put it simply. So how do I ensure that when I am training with a neural network? That is one question that needs to be addressed, that will be addressed in the next week. But without going to details, is the idea clear? Yes. So the only point I would like to highlight here is if you use a neural network, I cannot directly train with y minus y hat whole square. So I will be training in it. This is something that we call encoder decoder architecture. If you recollect, we were using this in UNIT before. So you first try to reduce the dimensionality, and then again you try to increase the dimensionality. This is used in UNIT. So the only difference here is the output in UNIT. The output is the segmented image. Input is the original image. Here input and output will be the same. Basically you train your output directly on your input instead of getting some new label data set. So can I call this an unsupervised or supervised? Is it an unsupervised or a supervised process? The process of this training, can I call it as unsupervised? Yes. So you can call this an unsupervised learning algorithm because I am not giving any labels to train this on. Okay. What is scale divergence? So that is again, say you have two, so it is essentially a metric. To put it very simply, it is a metric that will help you to compare whether two distributions are equal to each other or not. say you have some data, so you plot some histogram of that particular data and you got something like this. So this is for data set x1. And similarly, you have another data set x2, you have something else. So the question now is, if I want to compare this particular data distribution with another distribution, how close these two distributions are there. The metric that we use, KL divergence, is one metric for that. This is the last question on SVM classifier. Yes, it will be used on it will be used in variational encoders. So the idea again, like I was saying, it is with respect to how do you ensure that this whatever features that you learn here are independent from each other. And so okay, that will be discussed anyway next week, so we'll reserve it for next week. So this is the last question I have for this week. So this is on SVM. So SVM is already discussed in the course. So are there any queries on the algorithm? If not, the question here is straightforward. It asks you, how do you use can I use a gradient descent to train this SVM classifier? All that it asks is this. So if you have already gone through the SVM video, it should be straightforward. If not, the idea, maybe I can give you a brief intro. Say you have two variables x1 and x2 as your inputs, and say something like this. All we try to find is some particular boundary of it. Let us say this line is represented by y hat equal to something given in the equation as say w1 x1 plus x2 plus some constant, some intercept p. So this is somehow you are representing your line equation, and whenever this y hat is so say this class is labeled +1 and all the classes in this are labeled -1. So what we are trying to do is first we identify the support vectors are basically the points that are closest to this particular line. So in this case this one and this one. Next one is I try to find the distance between these. This is called the margin. What I will try to do is maximize this margin subject to the constraint that whatever misclassifications I am doing should be minimized. So that is what SVM does. Mathematically what we will try to do is how do I calculate this margin? So once I know these points, whatever these points are, how do I calculate the distance of the particular point? So I have the line equation and I know the point, say the point is a comma b. Okay, I already used b somewhere else. Okay, let us say a1 and a2 is a particular point. So how do we calculate the distance of the point from the line? Distance is given by, if you just substitute this in the equation, so it will be given by w1 a1 . This will be the distance, and if you have the other one as well, say the other distance, so this is support vector 1 and this is support vector 2. You substitute s1 in this equation, you get d1, and you substitute s2, you get d2. So d1 plus d2 is the total margin. So let us say this is d1. So total margin is given by d1 plus d2, and all I am trying to do is maximize this margin. So this d1 plus d2 is something that goes as your w square. So when I want to maximize this is equivalent to saying minimizing w square or the norm of this particular weight vector. Subject to the constraint that you have here is y hat is something whatever you are predicting times y is greater than 1. This is something, if you recollect, we have used previously as well. So if y hat is greater than 1 and y is equal to 1, in this particular scenario you have y hat times y to be greater than 1. If your prediction is wrong, essentially if y equals to 1 but you predicted a y hat that is less than 0, then this goes less than 1, and in that scenario this is something that needs to be added to your objective function. So how do you solve this problem? So the problem is this: you want to minimize this objective function subjected to this constraint. How would I solve this problem? Using a steeped gradient descent. Can I use a steeped gradient descent in the first place? So this is your constraint optimization problem. So can I use SZD for this? We discussed on something called penalty functions, if you recollect. Where you come up with a new objective function instead of the original objective function. So where your new objective function will be something like plus some constant. Someone actually mentioned about Lagrange multipliers as well previously, if I can remember correctly. So something like lambda times I had I by I, or summation of across your all the samples, you summation and then provide y hat times y minus 1. And then you try to minimize this function. Okay, the idea here is you actually place your constraint also in your objective function, and then you try to minimize the overall objective function. This is say penalty function. The only problem you would encounter here is it is not actually straightforward. The differentiation can actually be not straightforward, and you can have a discontinuous function, so your gradients might not always be defined. So instead of a gradient descent, there are algorithms developed separately only for SVM classifiers. We'll not go into the details of it, but the only point I would like to highlight here is the gradient could, like, basically this particular objective function could actually be discontinuous, so you cannot directly use a gradient descent function. All I would want you to appreciate is why is this particular function discontinuous. So you see, this particular term will get added only when the points are misclassified. So this is essentially where your misclassification happens. So basically, if your y is 1 and then your y hat is negative, then you should have a contribution from that particular term. And similarly, the other way around, if y is minus 1 and then y hat is positive, then this particular term should get added to it. Otherwise, this term should not be added into the objective function. So some of your data points will get added, some of them will not be added. So you would not have a very smooth function. So gradient will not be continuous. So you cannot directly use the normal way of doing it. So as long as you can appreciate that it is discontinuous, you are fine with this question. Are there any queries, or is it clear? Clear. Okay. Yeah, we have covered most of the parts for this week. Are there any specific queries you have, or otherwise these are the questions I have from my end? So we have covered on naive-Bayes SVM, and we also discussed on MLE for one of the distributions, a uniform distribution. One of the assignment questions asks you to find it for a Bernoulli distribution, but the idea is clear. This is how you do for a uniform, so you implement it similarly for the other ones as well. We discussed on what else? Yes. yeah, we have covered most of the part. So you have any other specific queries, then you can stay. Otherwise, yeah, feel free to leave the session. Thank you. I'll keep the forum open for discussion if you have any of the questions. Otherwise, you can feel free to leave the session. I'll just keep the forum open because some people might join a little late. It's only 6 and we have session till 7. So, to those of you who are still in the session, you have any specific queries or want to discuss something? Maybe I should. We are almost in 10th week, so maybe if you have some feedback. Actually, we are planning to have one extra session on 14th April, like 13th is Saturday, and then 14th we have one more extra session. So maybe I'll take up one coding problem as well on that, but on the last session instead of the theoretical one. So one of you has actually asked on pins, so I'm planning to take one on pins. So that particular person is in the session. Maybe we can discuss on that. I think he's not there in the session. Okay. Okay. So when you are doing the inference from your naive Bayes algorithm, you will be using this particular equation, right? So if you are using a uniform distribution, what will be the value of this probability of x1? For any value of x1, the probability is going to be 1. So you do not have any particular preference to any of these values of x. The same goes for the other one, and probability of y equals to 1 is something that is fixed throughout your once your training data is frozen. So if these values are not changing with your as your input testing data is changing, then you do not have any predictive power, right? For both class 1 and 0, this is going to be 1, this is going to be 1. The only advantage you get here is essentially when your data points are lying very far from each other, or say when you found out these values of a and b to be say 0.1 and 0.6. I'm just giving some numbers here. So if after you perform this mean and variance, you got the values of a and b to be 0.1 and 0.6. Then in that scenario, if your x1 is 0.3 and x2 is 0.5, what can you say about the p1 is going to be half and p0 is going to be half? Because both of these values are 1 and 1, you are just left out with this particular value. So this is the scenario you actually questioned before. So what to do if p1 equal to p0? You won't have any predictive power in that scenario, so you can't do anything here. Only for the data points like x1 equals to 0.05 and x2 equal to say 0.5 or something, this is when you have p1 equal to 0, and then your p0 will actually be some finite value, and you can say that it belongs to a different class. So your predictive power will be very limited in that, but when you are using a uniform distribution. That is again because in uniform distribution you are essentially assuming everything is equally likely. So you do not provide any much information by saying everything can happen. Clear? Yes. Thank you. Are there any other questions or queries or anything that you would like to discuss, or any feedback for maybe the future students of the course or for the upcoming sessions? Okay, if there are no questions, then maybe we can end the session for today. Okay, I think there are no questions. Thank you for joining. We'll end the session for today.